All right, welcome to page number 2 of the notes, 15.8 cylindrical coordinates. And so what we're given is we're given these equations in the cylindrical form. We're just going to describe in words the surface whose equation is given. So for the first one, r equals 5. R equals 5 tells you that the radius is just 5. So then we can interpret this in the equation I'm in highlighter mode, x squared plus y squared equals r squared, which is just going to be 5 squared. So x squared plus y squared equals 25. So we know that the surface is so I'll write this out. The surface is a circular cylinder with radius 5. And we'll just leave it at that. We could say the axis is the z-axis, but we'll just keep it there. All right, example 3. Identify the surface whose equation is given. So 2r squared plus z squared equals 1. So a good way to identify the surface is to change it into coordinates that we know. So that's why I went ahead and changed it to x squared plus y squared equals 25. For the second, I'm going to do the same thing. I'm going to change that to... I'm just going to highlight the answer. I'm going to change that to rectangular coordinates. So we know what r squared is. R squared is x squared plus y squared. So I'm going to go ahead and say, okay, we have 2x squared plus y squared plus z squared equals 1. Well, that just turns into 2x squared plus 2y squared plus z squared equals 1. And so from this, I'm hoping that you're seeing, oh, okay, this is the equation of an ellipsoid. So we have an ellipsoid centered at the origin. We could also tell what the x and y and z intercepts are by just making all of our x and y 0 to find the z intercepts, which that would just be plus or minus 1. If we wanted to find the x intercepts, we could just make y and z 0 and then solve for that. That would be plus or minus the square 1 over the square root of 2, and that would be the same thing also for y. So we could add on to this and say these are the x and y intercepts of the graph, but you don't have to. But if you wanted to, that's how you would do it. All right. So the last one is write the equation in cylindrical coordinates. So now we're going to convert a rectangular equation into a cylindrical one. It's not that complicated. We know what x and y are. X is going to be 3r cosine theta plus 2 sine theta plus z equals 6. Z doesn't change. Z stays the same. If we wanted to solve for z, we could do that. Z equals 6 minus 3 r cosine theta minus 2. Whoa, forgot my r there. 2r sine theta. And that's it. We could pull out the r if we wanted to, but we don't have to. And so there we go. I mean, you could have stopped there, and I would have been satisfied. Let's do the top. Again, we'll solve for, we'll get z by itself. So notice for b, I could pull a negative out and just get x squared plus y squared plus z squared equals 1. So then I can just get z squared by itself. Z squared is equal to 1 plus, and then on the right side, just have x squared plus y squared. And then I should have changed it to r squared. I don't know why I didn't. So plus this right there is just r squared. Z squared. So z squared equals 1 plus r squared.